Okay, so on this one, I'm going to show you how to apply what's called the binomial correction factor. So we're using basically the bell-shaped curve, the normal distribution to approximate binomials. I'm going to be doing number 32. So remember, they use the pi symbol. I like to call that p, just so that doesn't confuse you with the pi 3.14. But this problem is going to meet the criteria of np is greater than 5, or n times 1 minus p is greater than 5. So to work the problem, first of all, they want you to get the mean and the standard deviation of the random variable. And just to remind you that the mean is always n times p. That's from chapter 6. That's your binomial formula. So basically, you would take 40 and multiply that by 0.55. And I'm going to round this off. That's going to give you right at 22. That's going to be your mean. And then remember that the formula to get the standard deviation is the square root of your variance, which is np times 1 minus p. So if you plug this in, you'd have what? You'd have 22 times 1 minus 0.55, and then you hit the square root button. And I'm going to take this out to 2 decimals. It's right at 3.15. Now, to use this correction factor, I'm going to go ahead and give you a visual. I'm going to draw my curve right here. And on part A says we want the probability that x is 25 or greater. So I know that we just said the mean is 22. So 25 is going to be somewhere up here. I'm going to draw my line all the way to the top. And we want 25 successes or more, essentially. Now, the way you do the 0.5 is the correction factor from your book. My visuals, if you just follow this illustration, this works for every problem. You never want the 0.5 to be within this area. So if I'm going from 25 to the right, I'm going to subtract 0.5, and our number we're going to use is 24.5. That's going to be our estimated variable right there. We don't use 25, we subtract 0.5. You always want this correction factor number to be just outside the range. I'm going to then convert that into a z-value. So 24.5 minus 22, because that's your mean, and divide that by your standard deviation, which is 3.15, is going to give you a z-score that's right around 0.79. So then I do before, I look in my table, I find 0.79, which it looks like it's right there. That's 0.2852. So 0.2, don't write it down here. I'll write it up here. So 0.2852 would basically be the area from 0 up to that data point, and I want to get to the right of that, so basically I have to subtract that from 50%. So if I take 50% and subtract that, I get 0.2148. That essentially is your answer, would give you successes of 25 or more. So again, this correction factor 0.5, I'm going to show you by using visuals and the areas under the curve. Just remember, you never want the 0.5 to be within that area. It's always either going to be added or subtracted to make sure that it's going to be outside of the area. That basically works for all the problems. All right, so let's show you how that works in letter C. It says the probability that x is 15 or less. So I'm going to go ahead and draw my curve again down here. 22 is the mean. 15 is right there. Draw my line. 15 or less. So think about it. We don't want 0.5 to be in that area. So at 15, think real quickly, am I going to add or am I going to subtract 0.5? Well, clearly, I'm going to add 0.5 because I don't want to use the 0.5 within this area. So 15 plus 0.5 obviously gives you 15.5. I convert that to a z by subtracting the mean, dividing by the standard deviation. And that's going to give you right about a negative 2.06 would be my z-score. And whether it's a negative or a positive, I'm just going to look up 2.06. That's going to be way down here. And 2.06 looks like it's 0.4803. Okay, so 0.4803. Now remember, that's going to give you from this point, this 22, which is a z-score of 0, all the way down to that negative 2.06. Let me draw my line here. So this area basically is 0 to negative 2.06. So again, I'm going to have to subtract that from 50% to fill in the rest of half of that curve. And once you do that, you get 0.0197 as your answer. Okay. Now I'm running out of space, so I'm going to just erase this part and show you part D to how you look between two numbers. So let me erase this part. So now I'm back to part D, and just to remind you that n times p we said was what, 22, and the standard deviation we already calculated, we said was 3.15. So I'm going to draw my curve one more time, put 22 right in the middle, and we want between 15 and 25. So I know 15 is right there. I know 25 is going to be way up there somewhere. I'm going to draw my line, and I'm going to go ahead and say this is the part of the curve I want to find. Now I have to apply the correction factor with the 0.5 to both the 25 and the 15. So if I start with the 25, I don't want the 0.5 to be in that area, so I'm going to add 0.5. And on this one, I don't want 0.5 to be in that area, so I'm going to subtract 0.5 to that number. So I'm essentially going to have 14.5 for this, that I'm going to estimate for the 15 successes, and I'm going to have the 25.5 that I'm going to estimate for the 25 success number. So you got to convert both of them into z-scores. So 14.5 minus 22, divide that by 3.15, and take 25.5 minus 22 and divide that by 3.15. Now, if you took the 14.5, you're going to get about a negative 2.38. For the 25.5, you're going to get 1.11 as your z-scores. All right. So at that point, you look each of these z values back up in your table. 1.11 is 0.3665. And remember, let me draw my curve here. So that means from 0 all the way up to this data point, because remember, this is your 0 point, and this is your 1.11. Of course, that's your negative 2.38. From 0 all the way up to that data point, let me go back, 1.11 is 0.3665. And from 0 to the negative 2.3, I just look up 2.38, and that's going to give me, it looks like 0.4913. That would be basically that area. That's going to be basically that area. So what you do at that point is you combine them. So 0.4913 plus 0.3665 gives you 0.8578 is your answer. So again, I hope this helps. If you just review, if you draw your visuals and you can visualize the area under the curve that you're looking for, just remember that you always want the 0.5 correction factor to be added or subtracted to make sure it's outside of that range, and then just convert that number to the z value and do as usual, go back and look those up in the table. I hope this helps.